Imagine standing in the middle of a vast desert under a night sky ablaze with billions of stars. Each tiny point of light is a sun, potentially orbited by planets teeming with life, civilizations that might be gazing back at us just as we gaze at them. But here is the question that has haunted scientists for decades. Where is everybody? What if everything we thought we knew about life in the universe is wrong? Today, we embark on a journey through the evidence that challenges everything we believe. Get ready. We begin.
To grasp the paradox more deeply, consider the Drake equation, formulated by astronomer Frank Drake in 1961. It attempts to estimate the number of communicative technological civilizations in the Milky Way. N equals R star times Fp times Ne times Fl times Fi times Fc times L. Here, R star is the rate of star formation, about 7 per year in our galaxy. Fp is the fraction of stars with planets, nearly 1 thanks to missions like Kepler. Ne is the average number of habitable planets per such system, at least 1. Fl is the fraction where life emerges, unknown, but Miller-Urey experiments show amino acids form readily. Fi is the fraction where intelligent life evolves. Debated, on Earth, intelligence arose once in 4 billion years. Fc is the fraction that developed detectable communication technology, and L is the average lifespan of such a civilization, from thousands to millions of years. Even conservative estimates suggest thousands of civilizations, yet we detect none.
This is not merely an academic puzzle. The Fermi Paradox holds up a mirror to humanity. Are we truly alone? Or is there a barrier no civilization ever overcomes? In Act 1, we will trace the origin of this mystery, explain the core principles, and examine how the scientific community has reacted. The story didn't begin with Fermi. As early as 1933, Russian rocket pioneer Konstantin Tsiolkovsky wrote about a possible cosmic quarantine. Advanced civilizations might deliberately isolate us, the way we protect uncontacted tribes. But Fermi crystallized the issue, and in 1975, Michael Hart published a landmark paper titled An Explanation for the Absence of Extraterrestrials on Earth. Hart argued that if interstellar colonization is possible, a single civilization could spread across the galaxy in as little as 10 million years using self-replicating probes, an idea originally proposed by John von Neumann. So why aren't they here? It's as if Columbus discovered the Americas, yet no one ever followed. The core principle is scale. The universe is not just big, it is mind-bogglingly vast. Light from Proxima Centauri, our nearest star, takes 4.2 years to reach us. From the galactic center, 25,000 years. A civilization lasting just 1 million years, 1,000 times longer than ours, could dispatch probes to every corner of the Milky Way. Think of ants in Africa, unaware of ants in Australia. If ants could build ships, they would eventually meet. We are those ants, waiting for ships that never arrive. The central mystery is the contradiction itself. If life is common, why the silence? In the 1960s, Carl Sagan optimistically estimated millions of civilizations in his book Intelligent Life in the Universe. The search for extraterrestrial intelligence, or SETI, began scanning the skies decades ago, yet nothing. Telescopes like Hubble and the James Webb Space Telescope have discovered thousands of exoplanets. Kepler alone confirmed over 2,600, and missions like TESS continue the hunt. Planets like TRAPPIST-1e sit comfortably in the habitable zone, but no biosignatures, no technosignatures, no artificial signals of any kind. The scientific community's response has been mixed. In the 1970s, the paradox nearly killed SETI funding. Senator William Proxmire mocked it as wasteful. In the 1980s, Frank Tipler sharpened the argument. If von Neumann probes are feasible, the galaxy should be teeming with them.
Critics countered that this is more the Hart-Tipler argument than Fermi's original lunch table remark. Still, in the 2000s, philosopher Nick Bostrom at Oxford linked the paradox to the Great Filter, a hurdle that prevents most civilizations from reaching the stars. But the accumulating data push us toward an unsettling thought. Perhaps the Great Filter lies ahead of us. Amino acids have been found in comets, Rosetta mission, 2014. Subsurface oceans exist on Europa and Enceladus. If life is widespread, why isn't intelligence? This leads us into Act 2, where the evidence begins to mount.
In Part A of Act 2, Observations. In 1974, Frank Drake used the Arecibo Observatory to beam a deliberate message toward the globular cluster M13, 1,679 bits describing DNA, our solar system, and humanity. The distance, 25,000 light-years. Any reply would take 50,000 years. Meanwhile, projects like SETI at home distributed the search across millions of home computers. Still nothing. In 2015, billionaire Yuri Milner launched Breakthrough Listen, scanning millions of stars across frequencies from 1 to 10 gigahertz, with sensitivity capable of detecting an Arecibo-like radar, 10 to the 13th watts, from 100 light-years away. The Milky Way is 100,000 light-years across. Fast radio bursts, FRBs, discovered in 2007, release in milliseconds the energy the Sun produces over an entire year. In 2020, FRB 200428 was traced to a magnetar in our own galaxy. Yet some repeating FRBs, like FRB 121102, originate billions of light-years away. The energy scale is staggering, equivalent to dozens of suns. Natural explanations, neutron-star mergers, magnetar flares, dominate, but the patterns sometimes appear too regular, raising fleeting questions before natural causes prevail.
But this is only a tiny fragment of a far stranger picture. In 2015, the star KIC 8462852, now known as Tabby's star, exhibited irregular dimming of up to 22%. Comets were proposed, but the dips were too extreme and asymmetric. For a moment, megastructures like partial Dyson swarms were considered. SETI searched for artificial signals, none found. By 2023, James Webb observations confirmed vast dust clouds, yet anomalies like this keep the question alive. In Part B, Consequences. Over the last 5 to 10 years, new analyses have deepened the mystery. A 2018 paper by Anders Sandberg, Eric Drexler, and Toby Ord at Oxford's Future of Humanity Institute dissolved some of the paradox by showing that earlier estimates of life's probability were overly optimistic. Uncertainties span many orders of magnitude. In 2021, Robin Hanson proposed the Grabby Aliens model. Loud, expanding civilizations should be visible, but if we are early in cosmic history, we simply haven't met them yet. The most shocking recent insight ties the paradox to existential risk. If civilizations are rare, the filter may be self-destruction, nuclear war, climate collapse, or rogue AI. A 2023 analysis by Jacob Garrett suggests advanced AI could be a universal filter. These lines of evidence point beyond the paradox itself and toward humanity's own future. In Act 3, we widen the lens to the bigger picture.
In Part A, Theory. The leading framework is Robin Hanson's Great Filter, 1996. Alternatives include the Rare Earth Hypothesis, Peter Ward and Donald Brownlee, 2000. Earth is uniquely suited for complex life thanks to our large moon stabilizing axial tilt and Jupiter shielding us from impacts. Yet exoplanet discoveries reveal incredible diversity, weakening strict rarity claims. Key figures include Nick Bostrom at Oxford, Robin Hanson at George Mason University, and Avi Loeb at Harvard. The philosophical fallout is profound. If the filter lies ahead, humanity stands at a precipice. This forces us to rethink the very foundations of long-term survival. In Part B, the future. Upcoming missions offer hope. Euclid, launched 2023, maps dark energy and galaxy distribution. Plato, 2026, will hunt Earth-like worlds in habitable zones. Breakthrough Starshot aims to send gram-scale probes to Alpha Centauri using laser sails, reaching 20% light speed, arrival in roughly 20 years. Recent breakthroughs give us reason to expect answers soon, while expanding the scale to its cosmic maximum. If we pass the filter, the galaxy could one day be ours.
In Act 4, the deepest questions, the most profound implications reshape our view of reality. We may be among the first or the last. Unresolved paradoxes remain. Why no probes, no artifacts? Connections to other mysteries abound. Could dark matter harbor hidden signatures? 4 possible scenarios emerge. 1. We are truly alone. 2. The filter is ahead. Self-destruction awaits most species. 3. The zoo hypothesis. Advanced civilizations watch without interfering. 4. We live in a simulation where contact is forbidden. The deepest insights arise when we realize the silence may be a warning. In the end, we have traveled from Fermi's simple question to the brink of existential risk. We have learned that the universe may be quiet because of insurmountable filters, yet the mystery endures. The current scientific consensus, the search continues. The universe is vast, its secrets are endless, and our journey has only just begun.
Welcome to this exploration of one of the most profound mysteries in cosmology, the Fermi Paradox. Named after physicist Enrico Fermi, who in 1950, during a casual lunch at Los Alamos National Laboratory, simply asked, "Where is everybody?" This paradox highlights a glaring contradiction. The universe is immense, roughly 2 trillion galaxies, each containing hundreds of billions of stars. Astronomers estimate that the Milky Way alone could host up to 100 billion potentially habitable planets. If life emerges on even a tiny fraction of them, and if just a few of those civilizations advance to the point of interstellar travel or communication, why do we see no trace of them? No ships, no radio signals, no ancient artifacts? The silence is deafening, and it forces us to confront our place in the cosmos.
Let's start with the foundations. In 1950, Nobel laureate Enrico Fermi, builder of the first nuclear reactor, was discussing a newspaper cartoon about flying saucers with colleagues when the conversation turned serious. If the universe is 13.8 billion years old, and light-speed travel or signals can cover vast distances over millions of years, why aren't aliens here? Fermi made a quick back-of-the-envelope calculation. Even if advanced civilizations are rare, over billions of years, at least one should have colonized the entire galaxy. It's like scattering seeds in a fertile garden. The garden should eventually bloom. Yet our cosmic garden appears empty.